So we'll first start off with long division of polynomials. It's the universal technique that will work with any possible factor of a polynomial. This is basically the same as normal long division, but with variables. The first thing you want to do is put the number that you're dividing by on the outside and the number you're dividing on the inside. And as you can see, I put in a plus 0x because there's no single x term, and we'll keep that in there for now so that it won't be a problem later. To start this, you have to focus on this and this. How many times x will give you x cubed? It has to be x squared, so you will multiply x squared by x minus 3. So then you multiply x squared times x, which will give you x cubed. Then you multiply negative 3 times x squared, and you'd get negative 3x squared. You then put that in parentheses and subtract. You distribute this negative, so these two cancel out, and this becomes a positive, so you would get x squared. You then bring down this plus 0x and do that process again. So what times x will give you x squared? And that would be plus x, and you multiply x by x, which equals x squared. Negative 3 times x is negative 3x. Put it in parentheses and subtract. This becomes a positive 3x, and you're left with 3x, and then you bring down that negative 9. You do this one last time. What times x will give you 3x? And that would be 3. So x times 3 is 3x. Negative 3 times 3 is negative 9. Parentheses, subtract, and they all cancel out to equal 0. For this particular problem, since we got a 0, there is no remainder. Now we'll talk about synthetic division of polynomials. You can use this shortcut if you're dividing a polynomial by a first degree polynomial. So let's divide this problem, and the first thing you want to do is take the opposite of this number, and you get negative 2. Then you take the coefficients of this equation. You get 5, 8, negative 1, and 6. And the first thing you want to do is bring this number down. So you get 5. Then what you do is you multiply this number by this number and put the answer of that here. So you get negative 10. Then what you do is add the numbers down this column and you get negative 2. Then you do that process again. So negative 2 times negative 2 is 4. Then you subtract these two and you get 3. Then you multiply this by this and get negative 6, and you're left with 0. The rule is you can rewrite this as 5x squared minus 2x plus 3 because you make it a degree less. And this is our solution. So we don't have a remainder at the end, so there's nothing there. But if there was a remainder, what you do is put that remainder number over what you divided.
Division algorithm is the theorem that an integer can be written as the sum of the product of two integers, one a given positive integer added to a positive integer smaller than the given positive integer. To explain the division algorithm in simpler terms, we will be using the equation 225 divided by 11. The n represents your divisor, the q represents your quotient, the r represents your remainder, and the a represents your dividend. So in this equation, 225 divided by 11 is 23 remainder 2. Using synthetic division and remainder theorem, we will evaluate the following function: 3x cubed plus 8x squared plus 5x minus 7. Also, x will equal negative 2. Now, using synthetic division, we will evaluate the following equation. So first, you bring down your 3. Next, It's negative 2 times 3, which equals negative 6. Subtract, and you get 2. Then you multiply negative 2 with 2, and you get negative 4. And then you subtract again, and you get 1. Then you multiply negative 2 with 1 and get negative 2. And then you subtract that and get negative 9 as your remainder. To check our remainder, we will plug in negative 2 to our original function, and we find out that f of negative 2 equals negative 9, which is a point on the f graph. Now for factor theorem, we will be factoring the equation x cubed plus 2x squared minus 5x minus 6. The two factors we were given is x plus 3 and x minus 2, which we will be using synthetic division to figure out if they are truly factors. Now, using synthetic division, we will solve to see if x minus 2 is a factor of this equation. So, first we bring down the 1. Then we multiply 2 times 1, and we get 2. Then we add 2 plus 2 and get 4. Then we multiply 4 times 2, which we get 8. We add negative 5 plus 8 and get 3. Then we multiply 2 and 3 and get 6. And we get 6 and negative 6. We add them together and get 0. Since we got the remainder 0, x minus 2 is a factor of this equation. Now that we found out that x minus 2 is a factor of this equation, we will do the same again with x plus 3. And as you could tell, x plus 3 is also a factor of this equation. Now that we found out that x plus 3 is also a factor, we find our last factor, which is x plus 1. So f of x equals x to the third plus 2x squared minus 5x minus 6 is equal to x minus 2 times x plus 1 times x plus 3.
Next, we're going to be talking about the rational zero test, which relates the possible rational zeros of a polynomial to the leading coefficient and to the constant term of the polynomial. To use it, you need to start by listing all rational numbers whose numerators are the factors of the constant term, then list the denominators that are the factors of the leading coefficient. Okay, so let's try it with the example x cubed plus x plus 1. Like I said before, you find the denominator from the leading coefficient, and then you'll find the numerator from the constant term. And then you put in the factors, and as you can see here, it will equal to plus minus 1. And then you plug in the plus or minus 1, and as you can see here, because both of them don't equal 0, that shows that there are no rational zeros in this specific example. The next example we're going to use is x cubed plus 3x squared minus x. Here again, you'll find the denominator and the numerator by finding the factors to the numbers, and then you'll find it's plus minus 1 and plus minus 3 over plus minus 1, which will equal to plus minus 1 and plus minus 3. First thing is you plug in the 1, and then you'll find that it's the first rational zero. Then you'll plug in the negative 1 and find it to be the answer to be 6. Next 3, which you'll find to be 57. Then negative 3, which you'll find to be 9. And this shows that the only rational zero is 1 because it's the only one that equals 0 when you plug it into the polynomial. As you can see here, we're using the same example and the same rational zero that we found last time to use that rational zero to use synthetic division on this polynomial, so then we can factor it with that rational zero.